We will start by importing a TXF file. The current maximum size for the pit mesh is 64,000 vertices. Rotate the scene with the left mouse button, pan the scene with the middle mouse button, and zooming can be done in one of two ways. Press the right mouse button and move the mouse up and down. Rotate the mouse button wheel. Change the rotation point and scene center by double-clicking on any mesh, and center the scene by double-clicking on empty space. There are three default material interactions, with the first a special case used for water flows that I will show later. So that's the special case for water flows, and that's the first default rock and the second default rock. A new material interaction can be created by pressing New, Create Material Interaction, and this brings up this pop-up box. Anything can be written in the description box, and the coefficient of restitution can be determined in one of two ways, from velocities or from drop and bounce heights. So let's say you've got a rock, you drop it from 1 meter, it rebounds by a centimeter, then the coefficient of restitution is 0.1. So that's what I'll be using. Let's assume a friction angle of 45 static and a friction angle of 40 for dynamic, and that's the new material body interaction. Note that the material describes the contact properties between two surfaces, not the properties of a specific material. The body mass and the simulation, so that's the body mass, in conjunction with the density and the environmental settings, will determine the full body volume, the size of the full body. So let's select a full body shape from the toolbar before we start. Many aspects of the rockfall simulation can be changed to create a specific outcome. The time can be stopped with the Stop Time checkbox in the Simulation tab. Simulation tab, Stop Time checkbox. This is useful to set a scene before a simulation. Ticking the Real Time checkbox will run the simulation at the same speed as the rockfall should occur in real life. If the checkbox is not ticked, the simulation speed will be a function of the computer speed and memory. The trajectory path can be followed with frozen captions of the falling object, and distance will determine the frequency of these captions. The scale of the frozen mesh captions can be changed to follow small fall bodies, but all this will be illustrated in a moment. We will start by activating the rockfall mode using the toolbar button. The button is a toggle and activated when the background is turquoise. The Stop Time option is selected to stop the physics time and allow us to set up a scene. The Real Time option is selected to see the rockfall in actual time when the simulation starts. We will activate the Path Trajectory Mesh to follow the body rotations, and a high resolution is selected for a detailed result. So I'll do a caption every 1 meter. So let's set up the scene with different fall bodies by using the right mouse button to place the fall bodies, and the bodies are continuously generated if the button is pressed. The physics engine will start to calculate when we uncheck Stop Time. The right mouse button is used to place the full bodies, and bodies are continuously generated as long as the button is pressed. The bodies can be deleted by the Delete button and selecting Delete All Bodies, Meshes and Markers. To show selected delete, I will deactivate the trajectory path for a moment. Bodies can also be placed individually and mistakes can be cleaned up. Individual bodies can be deleted by selecting Delete Single Physics Bodies. The relevant body will be highlighted when the mouse hovers on top of it, and by pressing the Delete button on the keyboard, selected bodies can now be removed. Let's again activate the trajectory path before we continue. The material interaction selected at the time of the full body placement will be assigned to the full body. Let's investigate the effect of different material interaction properties on the outcome. The slope dips at roughly 37 degrees and can be measured with the measuring tool. (37.4 degrees). Let's place 3 boxes of each of the 2 defilled rock materials and see how the outcomes differ. And let's run the simulation. Material 01, the first 3 boxes, has a friction angle below the slope angle and the body thus slides, as you can see over there. Material 02 has friction angles above the slope angle and thus tumbles down the slope. And you can see that's exactly what happened. This one even got stuck and didn't move any further. This time we will place different shapes on the slope. Let's select material 02 for all the bodies and place a few shapes in a row. Let's start the simulation. And the outcomes for the shapes are very different as expected. Pressing the graph button will activate the graph mode to inspect the body velocities and energies. Let's just open up the graph slightly. You can also take the graph out and put it on a separate screen, but that's not possible in this video. And that's the outcome for the velocities. And you can also see the result directly below the mouse is given in this text box over there. Let's look at the energies. And the energies are split up into different components. So the bottom part, and let's open it up a bit more. The bottom part would be rotational energy, that's the translational energy, and that would be the total energy. And again, this would be the segment directly below the mouse button. Let's close this down a bit. You can also look at the trajectory path in a different way by pressing this button. This will give you a color-coded path of the results. And what you'll find is the red ones would be the high energy sections on the graph. So that's a different way that you can look at your results.